then you have to share to get a graph from Python. Firstly, we need to import libraries like quickly your PY plot and pandas to handle and manipulate data and create graph with a visualization. Second, create the dataset like df data equal open bracket with u in the independent variable section. Income RM is the dependent variable. Next, we need to convert to data frame. We put df equal pd.dataframe, open bracket data and close. So making it easier to analyze and plot. To create the figure, we put plt.figure, its size is width 12 and height is 6 inches. And then to plot the graph, we put plt.plot, open bracket df for year, df for income RM, and the label is total average income. In x-axis label is year, y-axis label is income, and then for the title is average income. And next, the format of the graph, we put plt.axis rotation for x-axis, plt.label format, inside plane for y-axis, plt grid to add a line grid, and then for plt legend is location for label on lower right, and the plt shows to renders and display the graph. I think that's all from me. Thank you so much. Kena dengar tapi next we run this code and module wait for the result. Okay, this is average income graph. Then save this graph on your file. I think that's all from me.
Okay guys, so for the next video, I will show you guys the tutorial how to write a Python script to visualize the Durbin-Watson statistical test for our econometric model. Okay, for the first thing first, we need to import the necessary libraries. We are using matplotlib for plotting the graph and skippy to handle the normal distribution functions. Okay, next, we define our critical values. As you can see here, we have set the DL and DU values based on our statistical table at the 5% significance level. We also include our calculated DW value of 1.392. Now, we use plt.plot to draw the distribution curve. To make it easier to read, we use the fill between function to highlight different zones, such as red for positive autocorrelation, orange for the inconclusive zone, and green for no autocorrelation, and so on. To mark our specific DW result, we add a vertical dash line. This helps us visually identify where our model falls within the test regions. Okay, and then once the code is ready, we just need to click run or click the button F5 on your laptop or your PC, and then click it. After that, click OK. Okay, after you run your code, you need to save your file like this. Just type Durbin-Watson test. Click save, and then you need to wait for a while, and then the file will show you like this. This is your graph, and that's it. Our visualization is ready. Okay guys, so let's move on to the F-test for our model significance. In this script, we are using NumPy for data points, matplotlib for plotting, and skippy to calculate the F distribution curve. And then, we have set our degrees of freedom to 3 and 32 with a significance level of 5%, which is alpha equals to 0.05. Our calculated F statistic or F star is 0.7172, while our critical value is approximately 2.92. Okay, next, we also add a PLT.fill between comment here to highlight the rejection region in light blue. This is the area beyond our critical value of 2.92. If our F statistic falls in this shaded area, we reject the null hypothesis. And finally, we run our code. So do the same thing like the other test, and then fill the file's name, and then after that click save. You need to wait for a while to show the graph. So this is the F-test graph. Okay, as the graph pops up, notice where the dot line for our statistic value 0.7172 is located. It is far to the left of the dashed critical line. Since it falls in the non-shaded region, we fail to reject the null hypothesis, meaning our model's independent variables are not jointly significant at this level.
To share a graph from affected. And this is for t-test graph. First, import libraries such as matplotlib, checker, numpy, and skippy. So this year Python ada data. For define the test values, df equal to 36. For the alpha equal 0.05 means 5% significant level. T critical from the table will T equated to which is T soft. For the generate the distribution curve, we put as equal at the space, which is create 1000 values from -5 to 5 for the x-axis, and the y equal to pdf open bracket df to calculate the probability density function on the t distribution. Next, for plot the graph, put plt.figure, plt.plot xy, for plt.asp line, for minus t critical and t critical to draw critical values for answer. And then to shade the rejection regions, we put some equation, which is plt.fill between open bracket xy where open x less equal minus t critical, and next for plt.asp line to draw a dash vertical line for the calculated t value, which is 1.0914. And then for level and title is the distribution curve, the 5% confidence level. X level is the Y level is probability density, and at test, which is plt.net, include the calculated 0.02 as threshold, and plt.show to display the final graph. Next, we run this code, save, OK, and wait for the results. Alright, this is the test graph. I think that's all from me. Thank you.